Okay, we're going to continue looking at factoring by grouping, and then we're going to move into the AC method as well. So if we look at this first one, if we factored by grouping here, I could group the first two, and if I group the first two, I would say that there is, what I first should do, I take that back. What I first should do always is look through all four terms, or however many terms you have, look to see if there's any constants or thing common throughout the entire thing. And in this case, there would be a 5 common throughout. So I'd factor out that 5 first. And now what I'd be left with is a w to the third minus 2w squared plus a 5w minus a 10. Okay, now with that factored out, I can look at factored by grouping inside of that. So inside of that, I'd be grouping the first two and the last two. And if you group the first two, you could see that there is a w squared common. If you factor that w squared out, you'd be left with a w minus a 2. If you look at the second two, we could see that there's a 5 common. So if you factor out the 5, you can see that there's a w minus 2 left. Okay, so now we go back to that same idea of what's common here, and we can see that there's a w minus 2 common. So if I factor out a w minus 2, you'd be left with a w squared plus a 5. The last thing you must remember is to bring this 5 that you had started by factoring out, bring that along with. Okay, if I would have done it using the box method, the first step would have been the same. I would have factored out the 5. So I'd be looking at, first of all, I'd have the 5, and then I'd have the w to the third minus 2w squared plus 5w minus a 10. Okay, if I looked at the box method from here, what would I be putting in the boxes? I'd be putting in a w to the third minus 2w squared, a 5w, and a minus 10. Okay, again, we would then look across columns and rows. If you look across the first row, you could see that there is a w squared common. If you look across the second row, you should be able to see that there is a 5 common. If you look across the first column, you should be able to see that there is a w common. If you look across the second column, you should see that there is a negative 2 that would be common. Some of you might be asking, how do you know if that's going to be a negative or a positive for this term and for this term? And the answer is by the box directly by it. So for instance, this negative 2, this box right here was a negative. If I looked at the 5, this 5w is a positive, therefore this would be a plus. So what do I get? Well, I've got this 5, and then from the box, I got a w squared plus a 5, and then the factor on top, which is a w minus a 2. Okay, I want you to pause the video and go ahead and try the next one. Okay, so we should have gotten this. I prefer the box method again, so I'm just going to go with the box method right away. The answer you should get by grouping obviously is the same. So I'm just going to go with my preference. So if I've set it up like so, and I look across that first row, I can see that there's an x squared common. If I look across the second row, I can again see that it's going to be a negative 6. If I look across the first column, I can see that there is an x common. If I look down the second column, I can see that there is a negative 1 common. So my factors, I would say, would be an x squared minus a 6 and an x minus a 1. Okay. The next method we're going to look at is called the AC method. And the first thing we should remember is, what are we talking about AC? Well, standard form for any quadratic is this, ax squared plus bx plus c. So if I were going to look at this and I looked at A and C refer to the 3. That would be your A, and the C is your negative 20. So the AC method means we're going to take A times the C. So I'd have 3 times the negative 20, which is a negative 60. Okay, so we need to keep that number in mind. In the meantime, again, I prefer the box method, so we're going to tie this in with the box method. So I know already that this is going to be a 3y squared. This I know is going to be a negative 20. The question is, what do these two boxes, or where are those two boxes coming from? And the answer to that is the negative 60. So what we're looking for now is factors of a negative 60 that will add up to a positive 7. So I start looking at my factors of factors of 60. I know that I'd have a negative 1 and a positive 60, or a 1 and a negative 60. I could look at a 2 and a negative 30, or vice versa. A 3 and a negative 20. I could look at a 4 and a negative 15. I could look at a 5 and a negative 12. A 6 and a negative 10. And again, I'm looking for pairs that would add up to a positive 7. And the way I have them written now, I don't have any pairs that would add up to a positive 7, but I do have some that add up to a negative 7. So I know from that all I have to do is switch to a negative 5 and a positive 12. Those two would multiply together to give you negative 60, but would add up to a positive 7. So those are the two numbers, along with a y, that I put in here. So I got a negative 5y, and I have a positive 12y. Positive 12y. And now, once I have that, I simply go back to that same process that I was doing, looking for common factors along columns and rows. So along this first row, I know that I have a 3y common. The second one, I have a negative 5 common. The first column, I can see that I have a y common. And the second one, I can see that I have a 4 common. Okay, so what would this factor into? I would say that this factors into then a 3y minus a 5 and a y plus a 4. Okay, you could have used the same idea and applied it to the grouping method. How would you have done that? Well, essentially what we're doing, we're looking for a way to split this middle term into two terms. So what are we looking for to split that into? That again is the same thing. The factors down here that add up to a positive 7, but multiply it together to give you a negative 60. So I would simply rewrite then this expression into 3y squared, a minus 5y, plus 12y, minus 20. And then I would go about my grouping method. Okay, so I would have grouped the first two, I would have grouped the last two. If I looked at the first two, I know I have a y common. What do I factor out? I would factor out a 3y minus a 5. If I looked at the second two, I could see that there is a 4 common, so I'd factor out a 4. And what would I be left with? I'd have a 3y minus 5. Okay, from there, once again, what's common? This 3y minus 5. So I could factor that out, 3y minus 5. And then I would have y plus a 4. Okay, so it's up to you which method you want to use. Again, my preference is the box, but you can apply it to the grouping method as well. Okay, if we move to the next one. Okay, I want you to just give it a try before watching the rest of the video and see what you can come up with. Okay, and hopefully you tried it. So again, my preference is the box method, so that's where I'm going to start. I'll do the box method. This is going to be a 6x squared. I know this is going to be a negative 20. AC tells me that I'm going to be multiplying a 6 and a negative 20, which would give me a negative 120. So what I'm looking for are factors of a negative 120 that add up to a negative 7. And again, this may take some time for you, but if you just make your factor pairs, you know you could have a 1 and a negative 120. You could have a 2 and a negative 60. You could have a 3 and a negative 40. You could have a 4 and a negative 30. You could have a 5 and a negative 24. You could have a 6 and a negative 20. You could have a 8 and a negative 15. And if you remember, we're trying to get to a -7. So if I look right here, I actually have a pair that add up to a -7 there. So I'll just stop. Okay. And I would know then that this is going to be an 8x. This is going to be a -15x. And then I go about my process looking around columns and rows. So if I look across the first row, I could see that there I have a 2x common. The second row, I can see that I have a -5 common. The first column, I could see that I have a 3x common. And the second row, I can see that I have a 4 common. Okay, so if you went back and tried to multiply these using the box method, or if you FOILed these two out, you would end up with what we started with. So we would say our factors here are 3x minus a 4 times a 2x minus 5. The only thing else I'll throw out, it does not matter the way you write these two. You could write it as 2x minus a 5 times a 3x minus a 4 as well. Okay. Another one, AC method. Let's see if we can quickly work through this one. First of all, the box. I got 2y squared, a 6. So I'm looking for 2 times a 6 is 12. I'm looking for two factors of 12 that add up to a 7. Hopefully we're fairly quick at this. And we can see that I'd have a 3 and a 4. So this would be a 3y, this would be a 4y. If I look at common factors now, I'd have a cross. The first column would be a y, second column would be a 2, or excuse me, a row. First column would be a 2 and a y. Second column would be a 3. So my factors would be a 2y plus a 3 and a y plus a 2. Okay, so hopefully that makes sense. I've got another couple here for you, but let's jump to this one. If I looked at difference of squares is quite simply, if I have an x squared minus 16, we could think of that as just a trinomial with no middle term. So what we're looking for is factors of a -16 that add up to 0. So hopefully we can see that it's just going to be opposites. So in this case, like an x minus 4 and an x plus 4. If I looked at the second one, 4m squared. Well, how did I get a 4m squared? Well, a 2m and a 2m. How do I get a -81? Well, if you think of a perfect square, the square root of an 81 is a 9. So it would be simply plus a 9 and minus a 9. If I looked at this next one, again, that's a perfect square. You may not see it exactly right away, but it is a perfect square. It would just be 6x to the 4th, y to the 3rd, minus 7m squared n. The other one would just be 6x to the 4th, y to the 3rd, and instead of minus this time, it would be a plus 7m squared n. Okay, I know I kind of rushed through that, but hopefully that made sense. Okay. So next thing is just to solve by factoring. So very quickly, we would just start by factoring it. This would be an h plus a 4 and an h plus a 2. These are equal to 0, so just applying that zero product property that I know we've talked about before, my solutions would be a -4 and a -2. On this one, first thing we'd do would bring the 12 back over, so I'd have an x squared minus 8x plus a 12 equals 0. If I factor that now, I know I'd have an x minus a 6 and x minus a 2. And then the zero product property would tell me that I'd have an x equal to 6 and an x equal to a 2. And again, hopefully I didn't rush too much. Hopefully that all made sense to you. And that one takes care of the second video on factoring.